For us to find the first three terms in this expansion, this is a second year binomial expansion because of the minus a half. Given this formula, so I'm just going to use it. I'm not going to talk about where it comes from or anything. It's like an extension of the first year binomial expansion. Okay, and note, we have to get it in the form 1 plus x to the n. And 4 minus x to the minus a half is not in the form 1 plus x to the n. So I've got a little step to do first. And you have to factorize out that 4. So I'm going to get 4 and then 1 minus x over 4. And we're raising all of that to the power of minus a half. So it's 4 to the minus a half. I can now separate it into these two things. 1 minus x over 4 to the minus a half. Okay, now 4 to the minus a half is actually 1 over 4 to the half, because that's what the negative means, which is 1 over the square root of 4, which is a half. Of course, you can use your calculator for this, but it's important to know that if you're ever dealing with it in terms of x. So a half times 1 minus x over 4 to the minus a half. So in our case, we've got n is minus a half, and our x as such is actually minus x over 4. That's the x that I'm actually putting in here. You could ignore the half and just multiply it through by n, but I always worry I might forget about it, so I'm going to put a big bracket with a half on the outside. Then it's going to be 1 plus n, which is minus a half, times x, which for us is minus x over 4. That's these two terms, and now I've got this one. So n, which is again minus a half, times n minus 1, which is minus 3 over 2. All over 2 factorial, or just 2, and then minus x over 4 all squared. Now there are other terms, but I'm just asked to find the first three. Okay, so I'm going to get a half, 1 plus 1 over 8x, because it's a half times a quarter. And then I'm definitely going to use my calculator for this next bit. I'm going to get, well, it's going to be, let me use the fraction button in fact. It's going to be minus a half times minus 3 over 2. The minuses are going to cancel, so I'm not even going to worry about putting that in. You can use the fraction button. You can also just take sort of little shortcuts. If I want to put it all over 2, I can just say I'm dividing by 2. So that's the first bit. And then I'm going to be timesing by x squared over 16. So I'm going to say 1 over 16. 3 over 128. Okay, and then finally, I've just got to multiply it out. So I've got a half plus 1 over 16x plus 3 over 256x squared. That is our expansion. In part 2, we're told that the expansion of a plus bx over 4 minus root 4 minus x is 16 minus x, and to work out what a and b are. So this is an interesting take on this kind of problem. Because often you get asked to actually expand the thing on the left, like with a and b given, whereas here we're having to sort of do a reverse and find out what a and b are. Now, the first thing to note is that that root 4 minus x looks very familiar because it is what we basically had in part 1. It's just there we had a minus. And that is the hint, really. You don't want to do a binomial expansion, like it's very tempted to do, just binomial expansion on the bottom, but actually what we would need to do is it's going to be 4 minus x to the power of a half. It's going to be a plus bx times 4 minus x to the power of minus a half. You can bring it up and then make it a negative, which is going to be a plus bx. And then I can just substitute in those terms I found in part 1. And remember, we're told that it's 16 minus x. Okay, so let's really focus on what's going on now to find a. Now, the only way I'm going to get a constant term is by doing a times a half. So I can basically say that a half a is equal to 16, which means that a is equal to 32. And actually, yeah, we're there on that bit. And then all I need to do is work out the x term. Okay, so now I can actually replace this by 32, just temporarily. All right, then I'm going to do 32 times 1 over 16x. That's going to give me 2x. 32 divided by 16 is 2. And I can also get an x term by doing bx times a half. So it's going to be a half bx. And that is going to equal the minus x term. Like, this is basically an identity. I should have said that. It's true for all values of x, in fact. That's how we can essentially equate the coefficients of the constant terms and then the terms in x and so on. So I can see that that's going to mean that a half b, I can actually just get rid of the x's now and just deal with the constants. That's going to be minus 1. So half b is actually going to be identical to minus 3. If I times through by 2, I can see that b is minus 6. Nice one.